Hello guys, welcome back to another good video. I am Ayush and today I am going to discuss NAND based or NOR based SR flip flop. In the previous video I described NAND based SR latch, but many of my friends um, told me that they have doubts regarding NAND based SR flip flop, so I am going to solve that doubt today. um, I'm uh, I will not describe it in the board. I'm going to describe it in my copy because NAND based SR flip flop is a um, huge topic. We have to describe key map or truth table, characteristics table and excitation table, so it is not possible to describe it on the board um, due to less space. So let's get started. So let's have a recapitulation. In the previous video we discussed NAND based SR latch. For making NAND based SR flip flop we require NAND based SR latch. So we will again recapitulate these terms or these states. For 00 it was invalid, for 01 it was set, for 10 it was reset, and for 11 it was memory. So let's draw the circuit of NAND based SR flip flop. Logic circuit. So as the heading it is written that it is NAND based SR flip flop. It means we have to draw NAND gate or we have to implement NAND gate in the circuit. So the circuit is like this. We are drawing NAND based SR latch here. So let's highlight this thing. NAND based SR latch, and we are naming the two output as Qn and Qn plus 1. Okay, and this is SR, and we have to put a clock here. Okay, so the circuit should be like this, and now we have to draw the truth table of NAND based SR flip flop. One more thing, if you want to use NOR gate here, you can use NOR gate instead of NAND gate. Just you have to draw the circuit like this. There should be two AND gates first, then you can use two NOR gates or NOR based SR latch here. The clock SR and Qn plus 1 NOR based SR latch. So you can do the circuit of SR flip flop using NAND gate or NOR gate. So but the truth table of both these will be the same. Okay, so now let's draw the circuit of let's draw the truth table of NAND based SR flip flop. S R Qn plus 1 result. So 0 0 1 1 0 1 0 1. Here we will also require a NAND gate because we have drawn here two NAND gates. So let's draw the truth table of NAND gate here. Truth table of NAND gate. S R S and R S and R whole bar. So 0 0 1 1 0 1 0 1 0 0 0 1 1 1 1 0. So we have drawn the truth table of NAND gate. Now let's implement the two things in the circuit of NAND based SR flip-flop. So the first term is 0 0. So let's write 0 here and 0 here, and you have to put another column here. The column name should be clock because we have implemented a clock here. So the clock should be 1. I am going to tell you why the clock should be 1, because now the value of clock will be 1 in all the cases. So let's put 1 here. Let's put 1 here. So both the values are 0. S is also 0 and R is also 0. So for 0 1 we get 1, okay, and for 1 0 we also get 1. So for 1 1, if we look at the table or look at the truth table of NAND based SR latch, we will find that for 1 1 it is memory, okay, for 1 1 it is memory. So for 1 1, or rather for 0 0, it will be q bar, okay. It means memory state. So let's find the second value, okay. So for 0 1 it will be 0 1, and here the R value of R is 1. So for 0 1 it is 1 again, and for 1 1 here if you look at the truth table of NAND gate, for 1 1 it is 0, it means 1 0. For 1 0 state we have reset, value is 0 1 and it is reset, okay. For 0 1 it is reset, and now let's go to the next state, that is 1 0. The value of S is 1 now and the value of R is 0. So for 1 1 it is again 0, and for 1 0 it is 1, okay. So for 0 1 we can see that it is set, it means 1 0. So it is set here and now at last let's write 1 1 here for both the cases. So from the truth table we can see that if both the values of a NAND gate is 1, then the output is coming as 0. So for 1 1 the clock is 1, and here the both the cases the clock is 1. So for 1 1 it will be 0, and for 1 1 again it will also be 0. So for 1 1 it is coming as 0 0. So for 0 0, if we look at the table of NAND based SR latch, we will find that for 0 0 it is coming as invalid. So we will put crosses here and we will write invalid. So if the clock is 0, it doesn't matter what are the values of S and R, it will be Q and Q bar, and the final result will be memory. Why it is happening here? Because if we follow the truth table of NAND gate, okay, we can see that if any of the input is 0, the output is coming as 1. So if the clock is 0, it doesn't matter if the value of S is 1 or whether the value of R is 1 or 0, it doesn't matter. If the clock is 0, it means the output of these two NAND gates will be 1 and 1. So for 1 1, if we follow the truth table of NAND based SR latch, we will find that for 1 1 it is Q bar, it means memory state. So if the clock is 0, it will be memory state. The truth table of NAND based SR latch is SR flip flop is finished. Now we will draw the characteristics table of NAND based SR flip flop. Okay, here we have to draw 4 columns and 8 rows. S R Qn plus 1 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. So as there are 3 inputs here, so 2 to the power 3 means 8 rows will be drawn here. So we will draw the characteristics table for the first 2 stages. The inputs are 0 0 0 and 0 0 1. For these 2 states we will put here 0 1 according to the Qn value. As the Qn value is 0 and 1, here we will put 0 and 1 in both the cases. Okay, so for solving the next or remaining 6 stages, we have to follow the truth table of NAND based SR flip flop. So for we have to follow these inputs. For 0 1 it is 0. For 0 1 again it is 0. For 1 0 it is 1 here. For 1 0 it is 1 again. For 1 1 it is invalid, and for 1 1 it is invalid. So the characteristics table should be like this. And now let's draw the excitation table, let's draw the K map. S R Q Qn. As there are three variables, there should be 8 cells here. So 0 1 0 0 0 1 1 1 1 0 0 1 3 2 4 5 7 6. These are the these are the cell numbers. So SRQN 0 1 0 0 1 0 1 1 1 1 0. So let's put the values for 0 0 1. For 0 0 1, it means this column, this cell here. So we will put 1 here. For 1 1 0 means 4, we'll put 1 again here, and for 1 0 1 we'll put again 1 here. For last two stages, for 1 1 0 and for 1 1 1, it is cross. So cross. So we can see that here it is a quad, and for here it is a pair. So here the first value is S. It is S because if we define the K map, the here it is a chord. So the terms are 1 0 0 1 0 1 1 1 1 and 1 1 0. So these four terms are here, and if we look at the four terms, the thing which is common between all the terms, that is the first one. So as the first variable name is, so we are putting is here, and as it is SOP, so plus here, and then for the pair it is 0 0 1, it is 0 0 1 and 1 0 1. So the common two things between these two is 0 and 1. So 0 1 means 0 means bar. Okay, for SOP 0 means bar, so R bar Qn. So it is the K map output. Okay, so now we will draw the excitation table. So at first I want to tell you that here for the excitation table there will be two inputs and two outputs. The two inputs are the outputs of the characteristics table, last two columns of the characteristics table, that is Qn and Qn plus 1, and the output will be nothing but S and R. So we are just shifting the output to the input and the input to the output. So Qn here and Qn plus 1 here, and S here and R here. So S and R are the outputs. So there will be 4 rows. Okay, 0 0 1 1 0 1 0 1. Here we will just have to look at the characteristics table, or we have to follow the characteristics table in this case. So we can see that if we avoid the crosses here, two crosses here, we will find that all the values are nothing but 0 0 0 1 1 0 1 1. It means we have to just underline these things. There are two 0 zeros. For 0 0 it is also 0 0, for 0 1 it is also 0 0, but in these two cases we just have to find the common thing. So 0 is common between these two rows, but for R, in the first case it is 0, but in the second case it is 1, so it is not common. So we will put a cross here. just follow these two rows. Okay, and for 1 1 we can see it is also two 1 1s here it is 1 1, and as well as here it is also 1 1. So if we look at these two rows, so we will find that the first value, it means here it is 0, the s value is 0 here and the s value is 1 here. Okay, so it is uncommon, so we will put cross here, and in these two cases the both the values are 0, so we will put 0 here, these two rows. Okay, and for 0 1 it is 1 0, for 0 1 sorry, for 0 1 it is 1 0, for 0 1 it is 1 0, and for 1 0 it is 0 1. Okay, we just have to avoid crosses here, we won't include that in our excitation table. So 6 columns are 6 rows are finished here. If the if any of the values are common between two rows, we will put the value. If the values are uncommon, then we will put a cross there. So the excitation table is this. Okay, so I am finishing the video here, because you just have to draw the logic circuit at first. You just have to draw the logic circuit first, then you have to draw the truth table, then you have to draw the characteristics table, then you have to draw the K map, and at last you have to draw the excitation table of NAND based SR flip flops. Okay, if you draw the NOR based SR flip flop, you will find that the truth table is also coming as the truth table of NAND based SR flip flop. So all the things should be same. Okay, there will be no change in both the cases. So I'm finishing the video here. If you have doubts regarding NAND based SR flip flop, you can comment it in the comment box. I will try to solve the doubts. Okay, so goodbye, take care, and have a nice day.